LPC2148 supports many interrupt sources. An interrupt source is the event generated by a peripheral that triggers an interrupt. Examples for this include timer 0 overflow, UART 0 receive or transmit event, ADC conversion complete, but the processor only has two interrupt lines, that is IRQ and FIQ. The hardware module that manages all these interrupt sources is called the Vectored Interrupt Controller. The Vectored Interrupt Controller, or VIC, is a hardware unit that manages interrupt signals from different peripherals. Its main functions include enabling or disabling interrupts, assigning priorities, routing interrupts to IRQ or FIQ, providing the address of the interrupt handler. Now let's discuss some of the important VIC registers. At first we have Vectored Interrupt Controller Interrupt Enable Register. This register enables specific interrupt sources. Then we have Vectored Interrupt Controller Interrupt Select Register. This register determines whether the interrupt will be handled as IRQ or FIQ. Then we have Vectored Interrupt Address Register. This register stores the address of the ISR. When an interrupt occurs, the processor reads this address and jumps directly to the handler. Then we have Vectored Interrupt Control Register. This register is used to assign interrupts to vectored slots. Slot 0 has highest priority while slot 15 has lowest among vectored IRQs. Now let's understand the working of VIC. Up to 32 peripherals generate interrupt requests and send them to the VIC. All the registers we are discussing here are 32-bit registers. At first, we have Vectored Interrupt Controller Interrupt Enable Register. This block enables or disables interrupts. In this case, each bit corresponds to one interrupt source, where if a particular bit is set as 1, it means interrupt enabled and allowed to proceed. Next, we have Vectored Interrupt Controller Interrupt Select Register. This block decides whether each interrupt is handled as IRQ or FIQ. 0, then IRQ, 1, then FIQ. FIQ has higher priority at the processor level. Interrupts selected as FIQ go directly to the processor. The processor jumps to the address 0x1c and executes the ISR. Next, we have Vectored Interrupt Control Register. Interrupt selected as IRQ enter this particular block. Each interrupt is assigned to a slot, that is 0 to 15. Slot number determines priority. Slot 0 has highest priority and slot 15 has lowest priority. The VIC selects the highest priority active interrupt. Next, we have Vectored Interrupt Address Register. Address of the ISR of the selected interrupt is placed in this register. Only one address is stored at a time. When the VIC sends an IRQ signal to the processor jumps to address 18, where an instruction loads the address from the Vectored Interrupt Address Register into the program counter and jumps to the ISR. After execution, the ISR clears the Vectored Interrupt Address Register. This informs the VIC that the interrupt has been serviced. If other interrupts are pending, the VIC selects the next highest priority interrupt, updates the Vectored Interrupt Address Register with a new ISR address. The Vectored Interrupt Controller enables interrupts, selects the IRQ or FIQ, assigns priority for IRQs, and provides the ISR address through the Vectored Interrupt Address Register, allowing fast and efficient interrupt handling.